So I thought I'd give a brief technical overview of the Pro DGX so you can see what's inside and kind of how it works. So this ARP Pro DGX is probably from 1978. I haven't looked too closely. The last one I did was from 78, but it was made up until about then, 78, 79. But it's based on the original ARP Pro Soloist from 1972. And many of you are familiar with two classes of analog synthesizers. There's pure analog synthesizers like Mini Moog and ARP Odyssey, where it's all knobs and switches and dials, and that controls all the routing. And then, later in the 80s and late 70s, there became microprocessor-based synthesizers like the Prophet, the OB series, Oberheim, even the ARP Quadra uses a microprocessor. The ARP Pro Soloist, even though it was made in 1972, implemented its own kind of digital routing for signals inside. So when you select these voices, a digital voice code will determine where your signal routes, which whether you have a pulse or square waveform, which filters and resonators get used for that to make the sound of the button that you click. Also, when you play on the keyboard, it's actually sending a digital code representing the key and octave that you've struck, which then goes to the waveform generator and generates the right it's a waveform generator or oscillator and generates the right waveform for that note. So in a sense, it's digital routing, and to do this, it uses these really old ROMs. And in the service manual, there's the truth table for these ROMs. They're 32-byte ROMs that basically determine for each voice which, where the signal will get routed. So like a 1 in this row would route the pulse wave to the high pass filter. 1 in this column or row would route the sawtooth wave to the high pass filter. So these ROMs are scattered all over the boards and kind of route the signal based on the voice that you've selected. Also, because there's no true oscillator that's using these digital codes to represent the note that you've struck, it's a reason that there aren't your MIDI to CV adapters won't work with the Pro DGX. And I kind of sketched up a MIDI adapter that would work with the Pro Soloist and Pro DGX. If there's any interest, mention in the comments, and maybe I can produce a couple of them. I just don't think that there would be enough demand to produce something like that. So to get inside the Pro DGX, there's 4 screws, here, 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 and here, and then you can open it up. Well, I'll leave it plugged in because I don't want to turn off the amp. So then you fold it open. The Pro Soloist is a lot more difficult to get to. You have to take the bottom off, and then all the boards you're looking at the back side of most of them. And it's kind of a difficult mess to work on that one. But there's 7 circuit boards inside. The power supply. Underneath the keyboard there's a board. The boards are numbered A through F, plus the power supply. So actually I'll start with A, which is the board with the slider controls. This is the waveform generator. Also, it kind of routes the values from the sliders to the other boards. Board B is this one right here. This is the envelope generator. Board C contains the filters. Most ARPs used a submodule for the voltage controlled filter, although there's some other filters on here like high pass, low pass, fixed filters, not voltage controlled. The ARP Pro DGX here is using a ARP 4075 submodule as the voltage-controlled filter. I sold recently an ARP Pro Soloist that had the 4034 submodule in it. And there's some trimmers to adjust stuff. So that's board C. Board D is tucked under here, and this is the board with the touch sensor effect switches. And as you guessed, this basically provides the touch sensor effects. Board E, actually board E is the one under the keyboard, and that converts what note you strike to the code and gate and trigger, which is routed to this board, the envelope generator, and this board, the waveform generator. Or sorry, the filters. Then these connectors basically transmit that on a data bus across the whole keyboard. So just because something's not connected directly, like the waveform generator is not connected to the keyboard, doesn't mean it's not getting the information from there. Board F is this one here, and basically this is the voice selection board. So based on what you hit on there, it will generate the code that's used by all these ROMs to determine the routing of the signal. So that's the inside of the keyboard in a nutshell. Then the first step with any of these ARP keyboards is going to be to recap it. And many people will just recap the power supply and the electrolytics on the power supply, but I don't think I wouldn't stop there with an ARP anyway. I would recap the power supply, including the tantalum capacitors, and then all these little blue and there's some red blobs on the other boards are tantalum capacitors, and they were very low quality ones that ARP used. They're damaged very easily, and when they fail, they short out, and it causes problems. So we're going to be using the Synthchaser ARP Pro DGX capacitor kit to recap this. And we're also going to rebuild the touch sensor, which is underneath here. In my store I sell a replacement aftertouch sensor bar that you can just remove this one and put the new one in, plug it in. I'm actually just going to rebuild the one that's here. But that's what I'm going to start with, and I'll show you the progress as I go through doing these basic things that really I wind up doing with most synthesizers that I restore. That's the full recap, rebuilding the keyboard and the key bushings, cleaning the key contacts, and in this case rebuilding the touch sensor.